Hello guys, I'm Osei Silas and welcome to the Mathlux. Don't forget to hit the subscribe button and also like the video. Let's begin. Today we'll be looking at binary operations. Now, what is a binary operation? So a binary operation is a rule for combining two elements to produce another element. So now let's consider operations on a non-empty set R consisting of real numbers by which we combine any two elements, that is x and y, which are members of R, to produce another element. Now let's take the set n, which consists of natural numbers 0, 1, 2, 3, then moving on. Then if we add any two elements of this set under a particular operation, such as addition, that is an example here 2 and 5, which are all natural numbers, to give 7, which is also a natural number, then mathematical operation of addition has been performed on the numbers 2 and 5 to produce 7. Addition is said to be a binary operation because it combines two elements of the set n, of the set of natural numbers n, to produce another element. So now other binary operations include subtraction, multiplication, division, intersection, and union. Apart from these basic operations, there are several other binary operations which combine two elements of a set to produce another element. So now let's see a binary operation star, which combines two elements a and b according to the rule 2 times a plus b plus the multiplication of a and b. So let's see, under this operation, combining 3 and 5 gives 6 plus 5 plus 15, which gives 26. So meaning that this binary operation combines 3 and 5 to give 26, which is also another element of the set of real numbers R. Let's see a worked example. A binary operation delta is defined on a set R of all real numbers by a delta b to give 2a minus b all on a squared plus 2, where a and b are all real numbers. Let's see. Now, combining the elements 2 delta 3, what do we get? We get 2 as a, meaning that we fix in the values of a and b. Now 2 is a and b is 3. So 2 times 2 is 4. 4. Now 4 minus 3 all on a square, which is 2. So 2 square is 4. 4 plus 2 is 6. Now what do we get? 4 minus 3 is 1. Then what is this? 1 over 6, which is also a real number. Now let's see 4 delta 5. What do we get? 2 multiplying 4 gives 8. 8 minus 5, where 5 is the b, and 4 square is 16, 18. Okay, so what do we get for this one? So we get 3 over what? 18. And we know that 3 can go into 18. 3, 1, 3 goes here, 3, 6, 18. So the answer is also 1 over 6. This is how you work on binary operations. So meaning that the binary operation delta combines two elements of a set of natural numbers of all real numbers according to the rule 2a minus b all on a squared plus 2. And these are the answers that we get. Now let's look at another element of binary operations. That is the closure. The closure. A set R is said to be closed with respect to a binary operation star if for any two elements a and b, which are all real numbers, a star b produces an element which belongs to R. That is, a star b is the answer we get should also be a member of R. Let me explain this further. Now, consider a set of numbers 1, 2, 3, 4, 5, moving on. Let's say the set ends at 5. Now, if we combine any two elements in this set, and the result of our combination according to a particular binary operation gives an element which is also a member of this set, then the binary operation is said to be closed. The set is said to be closed under the binary operation. So now let's look at a worked example. So supposing the binary operation star is defined on a set T 1, 2, 3, 4, 5 by A star B giving A plus B plus 2AB. This is the rule. So then 2 and 3 are both elements of T. 2 and 3 are both elements of T. But when we combine 2 and 3 according to operation star, we get something like 2 star 3. What do we get? According to the rule, we get 2 plus 3, which is 5. And 5 plus 2 multiplying 3 is 6. 6 multiplying 2 is 12. And our answer is what? 17. Our answer is 17. Now, 17 does not belong to the set of 1, 2, 3, 4, 5. So meaning that the operation star is not closed under the set T, because the member, when we combine any two members of this set according to the binary operation A star B giving A plus B plus 2AB, we don't get an element which belongs to the set T. So it therefore means that the set T is not closed under the binary operation star. Let's move on to properties of binary operations. Commutative operations, associative operations, and distributive operations are all properties of binary operations. Let's look at commutative operations. A binary operation star is defined on a set of raw numbers. They set to be commutative if A star B is the same as B star A. It should be noted. Now, let's look at one example. The operation star is defined on a set of raw numbers by A star B giving A plus B plus 2AB. Let's show that it's commutative. Now, from the rule, it says that A star B should be equal to what? B star A. Now, what do we get? The values of A and B interchange. So you get here to be A plus B plus 2AB, 2AB. And here too, this becomes our A now, and this becomes our B now. So this will be B plus A plus 2BA. We can't deny the fact that this and this, they are equal. If we rearrange everything, well, we get everything to be the same. So now, since A star B is equal to B star A, then the operation star is commutative. As simple as that. Let's look at associative operations. Now, a binary operation star is defined on the closed set R is said to be associative if for every element, that is A, B, which are all elements of R, A star B star C is equal to A star into brackets B star C. Let's look at a word operation. So now the operation sigma is defined over the set of raw numbers by A sigma B to give you A plus B plus AB all on 2. So now let's show using numbers whether or not this sigma is associative. This binary operation is associative. Let's see. We are using 2 and 3. 2 and 3. We use 2, 3, and 5. We use 2, 3, and 5 to prove it, whether it's associative. Now, according to the general rule, this is it. This is the general rule. So now let's see. 2 sigma 3. Then 5 here. All sigma 5. Then from the rule we say 2 outside sigma. Then what? 3 sigma 5. Let's see whether the operation sigma is associative. Now, so let's see, according to the rule 2 sigma 3, what do we get? We get 2 plus 3, which is 5. 5 plus 2, 3 times 2 is 6. Divided by 2 gives 3. Now 3 adding to 5, you get 8. Then we do A sigma 5. So we get here to be 8 sigma 5. Now let's see the other part too. So let's try 2 sigma, the result of this. Now, adding this, initially we get 8 here. Then 5 times 3 gives 15. 5 times 3 gives 15. 15 over 2 is 7.5. Now 8 plus 7.5, what do we get? We get 15.5. We get 15.5. So then let's punch everything in our scientific calculator and let's see our results. Now both give 33. Both give 33. Now since both give 33, then there's operation, then the operation, this one, sigma, is said to be associative. And that's it. Now let's look at distributive operations. Distributive operations. Let star and delta be binary operations, both defined on the set of closed numbers R, of closed set R of real numbers. The operation star is distributive over delta if for all A and B, A, B, C, which are all members of R, A star into bracket B delta C is equal to A star B, that is into delta into bracket A star C. So meaning this is all for the distributive operations. Let's look at identity and inverse elements. Identity and inverse elements. A set R is said to have an identity element E with respect to a binary operation star if for every element of A which is a member of R, then A star E is equal to E star A, which is equal to A. So a set R has an identity element if and only if the operation is commutative. Underline here. Is commutative. Now, what example? Let's look at the example. The operation star is defined on the set of real numbers by A plus B. We go to A plus B plus 2AB. Find the identity element. So now, according to the rule, it says that A star E as the identity element should be equal to E. Should be equal to E. Then, what is A star E? It is A. So A plus E plus 2AE should be equal to A. So then remove this A to cancel this A to, so it will make it 0 to subtract it. So here becomes 0. You factorize E out, you get E into bracket 1 plus 2A. We divide both sides by 1 plus 2A. Now we get E to be equal to 0. Meaning that the identity element is 0. Inverse element. Now the inverse element is very similar. So the element A, the A inverse of R is said to be the inverse element of A under the operation star with an identity element if E, that is A star is inverse, gives E. So now let's see, according to that general sigma, let's see. So mean that A star A inverse should be equal to A inverse should be equal to E. Now I had E to be 0 according to this operation. So then let's see what is more. So then this is A plus what? A inverse. Then what? Plus 2 A inverse E A to be equal to E. What do we get? We get our answer that A inverse is equal to what? E minus A all on what? So then we factorize it, then this gives 1 plus 2A. So there is it. So that's all for binary operations. You can have some trial questions. You try it on your own. So don't forget to like the video, subscribe to the channel, then turn on notifications. So thank you for watching.